You've seen it a million times in the movies, right? A tiny hole in a spaceship, and you hear this little hiss as the air leaks out. But what if I told you that's completely wrong? Today, we're diving into the explosive and, frankly, way cooler reality of what happens when air meets the vacuum of space. It's a wild journey from a supersonic blast all the way down to a single molecule's lonely trip across the cosmos. So let's set the scene. It's that classic sci-fi nightmare, you know? A tiny tear in a spacesuit or a catastrophic breach on a ship. We all picture that dramatic rush of air. But have you ever really stopped to think about it? Where does all that air actually go? And what's the real physics behind those frantic few seconds?
Well, the first thing you gotta know is that Hollywood, they get it totally wrong. It's not some gentle hiss or a slow, dramatic leak. Nope. The reality is far more violent, and honestly, a whole lot more fascinating. It's all governed by the fundamental laws of physics.
So let's get right into it. The reality isn't a leak at all. It's basically a high-speed explosion right into the vacuum. Think about it. You've got all this pressure inside a spaceship, and right outside, there's nothing. Absolutely nothing. That difference is so extreme, the air doesn't just, escape, it erupts. We're talking an explosion, outwards, faster than the speed of sound. It's a violent, instantaneous decompression. So, what's actually causing this insane explosion? To get that, we have to bust a huge myth. We always hear that space sucks things out, right? Well, the truth is, things aren't sucked, they're pushed. Yeah, that whole idea that space sucks is just not true. A vacuum, by its very definition, is empty space. There's nothing there to pull. The real force? It's coming from the inside. All that pressurized air in the suit or the ship is pushing itself out with just an incredible amount of power. This whole thing is driven by something called a pressure gradient. It sounds complicated, but it's pretty simple. Here on Earth, we're living under about 1 atmosphere of pressure all the time. But in space, it's basically 0. That huge, massive difference creates this overwhelming force pushing outwards. All those high-pressure molecules just violently rush to fill that empty space. Okay, so that's the big picture explosion. Pretty cool, right? But now, let's do something really interesting. Let's zoom in, way in. Let's follow the journey of just one single tiny molecule of air as it heads out into the cosmos.
So here on Earth, an air molecule's life is kind of chaotic. It's like it's in a pinball machine, constantly bouncing off other molecules, literally billions of times every single second. But the moment it escapes into space, everything changes. After that initial blast, it suddenly finds itself in this huge empty arena. It's free to just go, traveling in an almost perfect straight line.
And, of course, scientists have a name for this. It's called the mean free path. It's basically the average distance our little air molecule is going to travel before it smacks into another particle. Here on Earth, that distance is, it's microscopic. But in space, it's a completely different story. Get this. It's over 1,000 kilometers. Just let that sink in for a second. A single nitrogen molecule from that astronaut suit could travel the entire length of California, or fly from Paris all the way to Berlin, before it even has a chance of hitting another particle. That number right there tells you just how profoundly, unbelievably empty space really is. So why? Why does this happen? Why do all these molecules just spread out as far as the eye can see? Well, it's not random. It's not by chance. They're actually following one of the most basic, fundamental rules of the entire universe. And that rule is called entropy. It's a huge concept in thermodynamics. But to put it simply, entropy is just a measure of disorder or randomness. And one of the biggest laws of the universe is that everything tends to move towards more disorder over time. Think about the air inside that spaceship. It's all contained, it's organized. That's a state of low entropy. But when it explodes out into the vacuum, the molecules just spread out everywhere, as far as they can go. That's the universe doing its thing, naturally moving towards a state of maximum disorder or high entropy. That gas literally has no other choice. It has to expand forever. But that journey can't last forever, right? So after traveling for hundreds, maybe thousands of kilometers, what happens? What's the final, ultimate fate of these lonely little molecules? Well, they definitely don't just disappear. Depending on where they end up, they might freeze solid or maybe get zapped by some intense radiation. But ultimately, they all sort of blend back into the very fabric of the cosmos itself. Okay, so there are basically 3 main things that could happen. First, if they're far away from a star, the cold is so intense that any water vapor just instantly freezes into tiny little ice crystals. Second, if they get hit by solar radiation, they can get their electrons stripped away, turning them into what's called ionized plasma. But no matter what, they're all pretty much heading to the same final destination. And that final destination is something called the interstellar medium, or ISM for short. You can think of it as the super thin soup of gas and dust that just fills all the empty space between the stars. Our escaped air molecules, they just keep spreading out until eventually they just seamlessly become a part of that huge galactic soup. You know, the source material we're looking at today puts it in this really beautiful way. Each molecule ends up becoming a single particle floating alone in the darkness. It's amazing to think that it's just contributing its own tiny bit of mass to the sheer vastness of the universe. And that leaves us with one last kind of mind-blowing thought. Think about it. Every single time a rocket has vented gas or a satellite has used its thrusters, tiny little pieces of our world have been let go into space. So does that mean that right now, particles from our own atmosphere are out there traveling on a one-way trip between the stars? Pretty wild, right? Something to chew on. Thanks for joining me for this explanation.